This is part 2 of the lecture on diurnal motion. We can now use this diagram of the celestial sphere to explain why the sky looks the way it does from any vantage point on the Earth as the Earth rotates over a 24-hour period. As I go through this description, however, we're just going to talk about the stars. I'll get to the sun a little bit more in detail a little bit later on when we describe the seasons and also the sun's eastward motion. We'll get to those topics, however, a little bit later. For now, we're just concerned with the daily motion, the diurnal motion of the stars, and also the sun, if we wish to describe it in this manner. Okay, now what I'm going to do is I'm going to take an observer and position the observer at a couple of different points on the Earth. For example, let me take that observer and first of all put that person or that observer at the North Pole. Like so. Okay, now if you stand at the North Pole, what does the sky then look like? Well, what I want to do is I want to draw the dome of the sky that the person would see if standing at the North Pole. In order to visualize this dome, however, I have to picture the person's horizons. Here's how I would do so. The first thing that you have to remember is that the celestial sphere is of essentially infinite size. So then therefore we have to think of the Earth here as a point at the geometrical center of the diagram. And then this observer's horizons would be drawn, for example, as a line that is tangent to the surface of the Earth at that person's location. If we think of the Earth as a point here at the center of the diagram, that line representing the horizon goes off in these directions like so. So then therefore, if you stand at the North Pole, you then see the northern half of the celestial sphere as the sky. That is then drawn in the following way. Okay, so first of all, if you recall from an earlier series of lectures, when you stand on the surface of the Earth, it looks like you're standing in the middle of an enormous circle called the horizon circle. So here's my observer. And then the sky looks as if it's a hemispherical dome overhead, like so. Okay, the point directly above, if you recall, is referred to as the zenith. Okay, now, if you stand at the North Pole, what is every direction? Every direction is south. And the reason for that is because all the lines of longitude, which describe east and west, converge at the poles. So then therefore, if you stand on the North Pole, there is no longitude. And then therefore, if you take a step in any direction, what you have done is you've taken a directional step to the south. So all directions south. Okay, now compare this diagram I'm beginning to construct to the diagram above. If you stand at the North Pole, where in the sky is the North Celestial Pole? It's straight up like so. At the zenith, we can see that from the diagram above. Okay, and then where is the celestial equator? Well, recall from the diagram above that you have to think of the Earth here as a point in the center of the diagram. And then as I indicated earlier, if you stand at the North Pole, your horizon goes off like this. This then means that the celestial equator coincides with the horizon if you stand at the North Pole. Like so. And now this observer looks at the star. From the diagram above, the person sees the star to the lower right-hand side. Let's say like so. And then as the Earth rotates in a 24-hour period, from our vantage point on a rotating platform, we then see the celestial sphere completing a rotation. This then means that that star traces out its diurnal circle parallel to the celestial equator. That's parallel to the horizon if you're standing at the North Pole. Like so. Notice that the star does not rise or set. So if you stand at the North Pole, you're never going to see the stars rise or set. They are always going to circle parallel to the horizon. As I mentioned earlier, if you stand at the North Pole, you can see the entire northern half of the celestial sphere. However, notice that you cannot see the southern half of the celestial sphere. The southern half of the celestial sphere is below the horizon, and you're never going to see it for that reason. Okay, now what I'm going to do is I'm going to take my observer and move that observer to a couple of other locations on the Earth. Let's go ahead and take the observer and move the observer down to the equator. Okay, so on this main diagram now I take the observer and position the observer like so, here at the Earth's equator, and then once again I want to draw the dome of the sky that the person would see now from this vantage point. In order to get that dome, however, I have to picture the person's horizons. I would do so in the following way. Once again, we have to think of the Earth here as a point in the center of the diagram, because once again the celestial sphere is of essentially infinite radius. And then therefore, if we think of the Earth as a point here at the center of the diagram, then this observer's horizons would look like this. It would be drawn tangent to the surface of the Earth at that person's location, like so. So notice that the person's horizons then intersect the north celestial pole and the south celestial pole. On the board below, that diagram then would look like this. Okay, so once again, now we have the observer at the equator. Here's the horizon circle like so. Here's the observer. Here's the sky. Here's the zenith. And then the way that I have drawn this is that off to the person's left-hand side like so, the north celestial pole intersects the horizon. And then off to the person's right-hand side like so, the south celestial pole intersects the horizon. Notice that the celestial poles intersect the horizon at these two locations. These are the directions due north and south by definition. Okay, now this semicircular line that I've drawn here on this diagram, this line has a name. It's referred to as the meridian. The meridian passes through the celestial poles and it passes through the zenith. Where the meridian intersects the horizon over here, by definition, is due south. Where the meridian intersects the horizon over here, by definition, is due north. Okay, and then we have the celestial equator. So through what point in the sky does the celestial equator pass through if you're standing at the Earth's equator? Well, notice that if you're standing at the Earth's equator, the celestial equator passes straight overhead. It passes through the zenith. So then therefore here on this diagram below, I would draw that in the following way. Like so. Notice that the celestial equator, let me label it as such, intersects the horizon of these 2 points, here and here. By definition, those 2 points are east and west respectively. So east is not just some vague direction that way. West is not some vague direction that way. Instead, by definition, due east and due west are these points here and here where the celestial equator intersects the horizon. Notice that on the horizon circle, there is a 90-degree angle between due north and due east. There's a 90-degree angle, for example, between due south and due west, like so. Those 4 points are all separated by 90 degrees. Okay, and then we're taking a look at this star on the celestial sphere. On the diagram above, notice that I've drawn the star here on this person's meridian right here to the upper left-hand side of the diagram below. That then looks like this. And then as the Earth rotates, we would then see that star trace out its diurnal circle parallel to the celestial equator. So if you were standing at the equator, you would see this star rise straight up in the northeast, hit the meridian, and then set straight down in the northwest. Over a 24-hour period, if you ignore the sun, notice that if you stand at the equator, you can see the entire celestial sphere. You could see the entire northern half of it, and you can see the entire southern half of it. So if you could, for example, walk from the North Pole to the equator, you would start out by seeing just half of the celestial sphere at the North Pole, the northern half. You would see the southern half, by the way, the South Pole. And then if you walked from the North Pole to the equator, you would then see more and more of the celestial sphere, eventually seeing the entire celestial sphere. Now here in Los Angeles, of course, we don't live at the equator, nor do we live at the North Pole. So then therefore, what does the sky look like from here in LA? Well, for Los Angeles, our latitude here in Los Angeles, depending upon where you are in a city, is roughly 32, 33 degrees north latitude. So let's say, for example, that I position the person like so here on the Earth. And now I have to picture that person's horizons. For this example, let me just go ahead and draw that person's horizons in the following way. I'll do so as a dotted line here that is tangent to the surface of the Earth, passing through the person's feet at that person's location. And then therefore the dome of the sky that the person would see is right here on the diagram like so. And now I just have to reproduce that here on the lower board. That then looks like this. Okay, so once again, here's the horizon circle. Here's my observer. Here's the dome of the sky straight overhead. Here's the zenith. Okay, now the person looks to the upper left-hand side and sees the North Celestial Pole on an angle in the sky, like so. Notice that the North Celestial Pole forms an angle here above the horizon, like so. The angle that the North Celestial Pole is above the horizon is equal to the person's latitude. So from here in Los Angeles, if the latitude is, say, 33 degrees north, then the North Celestial Pole is at a 33-degree angle here above the horizon. This is roughly similar to, for example, the vantage point that you saw in my screencast describing star trails photographs for the person who took that photograph. The person who took that photograph was basically pointing her camera on a tripod at an angle here above the horizon, pointing it towards the North Celestial Pole. Okay, now the celestial equator. The celestial equator on the diagram above passes to the person's lower or upper right-hand side, like so. So here is the celestial equator, like so. In terms of being careful in drawing this, notice that there's a 90-degree angle between the North Celestial Pole and the celestial equator, like so. Here is due south. Here is due north, here is due east, and here is due west. So from here in this classroom faces in this direction towards the south. This way is west, this way is east, and north is in this direction here in this classroom. So imagine, for example, walking down the hall in that direction, say after class, and then you look in the sky like so from east to west, and when you do, you see the celestial equator in the sky, like so. Okay, and then we have this star. The way that I have drawn this star on the diagram above is that from this person's observation point or vantage point, the star is on the meridian, but it is south of the zenith, like so. That, for example, on the diagram below, would look, say, like this. And then over a 24-hour period, as the Earth rotates, we would then see that star trace out its diurnal circle parallel to the celestial equator. That would then look like this. We would see it rise in the northeast, hit the meridian, and then set in the northwest, like so. So by using this idea of the celestial sphere, as the Earth rotates, we can easily explain why the sky looks the way it does from any vantage point here on the Earth. From here in Los Angeles, notice that we could see a little bit more than half of the celestial sphere. We can see the entire northern half of the celestial sphere and a portion of the southern half as well. Portions, however, of the southern half of the sphere are below the horizon. We would never be able to see those portions. So, for example, from here in Los Angeles, notice that you're never going to be able to see the South Celestial Pole. It's always going to be below the horizon. Okay, this concludes this brief lecture on diurnal motion.